Alright, welcome to Master's PVD Tutorials. And this is your one and only one, Professor Lisa. Yeah, or Prof. Liu. You can also call me a Chapter Frederick. Yeah. Okay, so today we are going to look at arithmetic, geometry, and harmonic inequalities. Harmonic inequalities. And we say that if A, B, and C, let's say they are sequences, alright, sequence of what? Numbers. So, but we are saying that this is that they are greater than what? 0. That means that it can't be in terms of what? 0. Or the numbers can be what? Negative what? Numbers. But numbers that are what? Above what? 0. That means from 1 to what? Positive infinity. Alright, so we are going to represent the arithmetic mean as AN. And we know that if you have this and you are finding the arithmetic mean, you first use the first two numbers, and that will be A plus B, all this over 2. So that will be the arithmetic mean. And you also know that the geometric mean too will be the square root of what? The two numbers, which is A times what? The B. Very good. And harmonic mean too is the same thing, but with the harmonic mean, what we do is that when you pick two numbers, okay? Sorry, let me get rid of this. For some reasons. Alright. So since there are two numbers, that will be 2 over. Then I take an inverse of what? The inverse of A will be what? 1 over what? B. Plus the inverse of, and the inverse of B will be 1 over what? B. So that is what we are going to get for the harmonic mean. Alright, so having these two things, now that then we are saying that the arithmetic mean, that is what? AN is greater than or equal to the geometric mean. And that is greater than or equal to what? The harmonic mean. Alright, so that is that for that. So we are going to show or prove whether that is true or not using this procedure. So let's first consider, we can consider the three of it together like that. So let's first consider the arithmetic mean and the arithmetic mean and the geometric mean. And the geometric mean. So, considering the arithmetic mean and the geometric mean, we first write that for the arithmetic mean, and that is A plus B over 2. Please, is it that always here will be 2? Pacho, no, it's not like that. It's not like that, please. We are picking here to be 2 because we only have two numbers be in what? Consideration here. That is why I clear off the C. And here too is the same thing. We have 2 here because the numbers in consideration is what? 2. That is the one in the sequence 4. So we are going to say that we are going to assume that A plus B over 2 is greater than or equal to the geometric mean. And the geometric mean is what? Square root of A times what? The B. Very good. So here we apply our algebra and go. So to remove the square root, what will you do? You square both sides. So A plus B over 2 all squared greater than or equal to square root of A times B all squared. Very good. So having this, please, this is just algebra. Okay, this is just algebra. And I trust your algebra is good. Alright. So here we are going to get a plus b all squared over 4, because the square here will affect the what? The 2 here. Alright, and yet we get greater than or equal to. This one will clear up this, so we get a times what? The b. Very good. Now, when you get to this side, then we do a cross what? Multiplication. And when you do a cross multiplication here, we know that this is the same as what? 1. So we get a plus b all squared greater than or equal to what? 4ab. Then, algebra. This is going to give us what? A squared plus 2ab plus b squared. You can also multiply it by itself and you are going to resolve in the same thing. Okay. So, greater than or equal to 4ab. Now, let's bring everything to the left hand side and equate the right hand side to be equal to what? To be greater than or equal to what? 0. So, a squared plus 2ab plus b squared greater than or equal, sorry, as I said, we are bringing to the left hand side, minus 4ab is greater than or equal to 0. Alright, so that is that for that. Let's try to simplify it. We know that here is ab, here is ab, so we can subtract this from this. So here we get a squared minus, all we can see from there, a squared minus, sorry, plus b squared, this and this will give us minus 2ab greater than or equal to 0. Alright, so having this, it's still algebra. Excuse me, it's still algebra, alright? So having a squared plus b squared minus 2ab all squared equal to 0. Now, if you have this is the same as, you can see that this is the same as the expansion of a minus b all squared. How you can see that? Because this will give you a squared. Then multiply these two throughout to get minus 2ab plus what? This, which is what? B squared. Alright? And when you square the whole of this, here will not be what? Positive. Sorry, it will not be what? Negative. So this, writing this form is the same as writing it in this form. So don't forget that algebra. And we are saying that this is greater than or equal to what? 0. This is greater than or equal to what? 0. Alright, so we have established that. So now, let's move to geometric mean and harmonic mean. We are also going to combine geometric mean and what? Harmonic what? Mean. So for geometric mean, so we have first consider this and that. Alright, please let's continue. So we consider the arithmetic mean and the geometric mean, and we arrive at this. Now the question is, what does this mean? This means that firstly, initially we said that our values of our sequence A and B is greater than what? 0. And if it's greater than 0, then that means that what we're having here means that when we subtract the second one from the what? From the first one, we are going to get a value that will be greater than or what? Equal to what? 0. And if this statement is a true statement, then that means that our arithmetic mean is truly greater than or equal to what? The geometric what? Mean. I hope it's clear. Okay. So now, we are going to consider the second statement. The second statement, which says that, so this one is the first. Okay, so for the second statement, we are saying that what if, let's assume that the geometric mean is greater, let's consider the geometric mean and the harmonic mean. And we are saying that this is truly greater than this. And if this is greater than this, then let's go and see if truly that geometric mean is also greater than or equal to the harmonic mean. And if the geometric mean is greater than or equal to the harmonic mean, then straightforward, the arithmetic mean will also be what? Greater than or equal to what? The harmonic what? Mean. Because if this is true, then this to this will be true. Alright? If this is true, then this to this will be what? True. So let's consider that. Okay, so let's consider that the geometric. So to prove that the geometric mean is greater than or equal to the harmonic mean, let's prove it from or by considering the coming. All right. Alright, so to consider the geometric mean and the harmonic mean, whether the geometric mean is greater than or equal to the harmonic mean or not, we are going to prove from the arithmetic mean and the harmonic mean, and the arithmetic mean and the geometric mean rather, and the geometric mean and the geometric mean. Alright, the harmonic, the arithmetic mean and the geometric mean. So let's move on. We know that for the arithmetic mean, we have this to be a plus b over what? 2. And we are saying that this is greater than or equal to what? Square root of what? AB. Alright, so from here, we are going to do something so simple, alright? We are going to generate this to this idea and you will love it. So please watch more. From here, we are going to, for A, we are going to substitute A to be 1 over A, and substitute B to be 1 over B. The idea is that we want to generate this to a harmonic what? Mean idea, and that is taking the inverse of the what? Of the A and the what? And the B. So when you take the inverse of this, it's the same as you doing the substitution of 1 over A to A, 1 over B to what? B. So when we take the inverse of this, we get this, plus the inverse of this, we get this. All these over what? 2. So that is what we are having for that. And we are saying that that will be greater than or equal to. And in the same way too, we are going to also take the inverse of this. So here we are going to get 1 over A times 1 over what? B. So that is how we take the inverse. Alright, so having this, then we are going to apply our algebra here. We are going to apply our algebra here. Please, is what? Greater than or what? Equal to. So if this sign is greater than or equal to, and we change it to, we are saying that this is an inequality sign, okay? If let's say you are dividing, when we were in our junior high school, when you are dividing a negative number of both sides of an equation, we are saying that you change the sign. So what we are going to do here is that we are going to take the inverse of this. Alright, so when we take the reciprocal of this, we get 2 over 1 over a plus 1. We are transforming it to be a harmonic what? Mean. So that is that. So we are taking the reciprocal of this, so the reciprocal of this side, the left hand side, is going to affect this. So this one, we take the reciprocal of it, and here too the same thing. When you take the reciprocal of this, know that this is the same as square root of 1 over ab. That is what we have here. And taking a square root of 1 is the same as what? 1. So what we have here is the same as 1 over square root of what? ab. And when you take the reciprocal of this, you are going to get square root of what? ab. Beautiful, beautiful. So that is all what we want to get. And you can now see that this is what? A harmonic what? Mean. And this is what? A geometric what? Mean. So we have established that this geometric mean is greater than or equal to what? This what? Harmonic mean. In other words, the harmonic mean is less than or equal to what? The geometric what? Mean. And if that is true, then our statement is true that the harmonic mean is greater than or equal to what? The geometric mean. And that is what? Greater than or equal to what? The harmonic what? Mean. So that is what we applied here. Please here, don't be confused, alright? What we did is that we replaced to consider whether the geometric mean is greater than or equal to the harmonic mean. What we did is that we consider it from what? The arithmetic mean and the geometric what? Mean. So you can see that here the arithmetic mean is this, the geometric mean is this. And when you take the inverse of A and the B, you are going to get something like this, and the same thing applies to this side. Having this time this is 1, this time this is that. But when you take the square root of 1, it's the same as 1, and the square root of this is the same as what? A. Alright. So here, what we do is that we want to transform this to what? A harmonic mean. And transform this to what? A geometric mean. So if you want to transform this, you have to take a reciprocal of it. And when you take a reciprocal of AB, you get BA. In the same way, when you take the reciprocal of this, the 2 will come up, then this one will come down. And that establishes the harmonic mean. Very good. And when such happens, you have to change the what? The sign. You have to change the sign. So you change the sign to what? Less than or equal to. And this one too will be, the reciprocal of this will be square root of what? 80. So simply, we have seen that the harmonic mean is less than or equal to what? The geometric mean. And if that is so, that means that the geometric mean is also greater than or equal to the what? The harmonic mean. And if the geometric mean is greater than or equal to the harmonic mean, therefore the arithmetic mean too is greater than or equal to is equal to what? The harmonic mean. Thank you. So that is that. Now we are going to look at example concerning what is just taught. Alright, let me go for the example. Okay. Okay, so our example is ready. So let's look at it. Given that the sequence, given that the sequence 62, 65, 70, 75, 78, and 80, 62, 65, 70, 75, 78, and 80. Find the arithmetic mean, geometric mean, the harmonic mean. Alright, so we have been given these questions to try our hands on it. Alright, so let's start. So the we have been given sequence, and the sequence are 62, 65, 70, 75, 78, and 80. So to find the harmonic mean, to find the arithmetic mean, let's know the number of terms, okay, in the sequence. So how many terms? 1, 2, 3, 4, 5, 6. So we have 6 terms here. Alright? And don't forget that we are saying that if A, B, and is greater than 0. So you can see that the sequence here, they are greater than what? 0. And the number of terms here is what? 2. Sorry. The number of terms here is 2. So that is why you were given A plus B over 2. As I said, it's not always 2. It depends on the number of what? Terms. So looking at this question, we have 1, 2, 3, 4, 5, 6. So we have to add all the sequence. We add all the sequence. Hope you can see that. Then we divide all by 6. So 1, 2, 3, 4, 5, 6. Then we divide all by 6. And when you punch on your calculator, you are going to get, my calculator is here, but I have the answer also here. So let's write and go my way. 71.06. So that's going to be the answer for that. Alright, so that is 36. 71.36. So that is going to be for the arithmetic. 71.67. Let me put it. Alright, let's try and see. Take the calculator to 62 plus 65 plus 70 plus 75 plus 78 plus 80, all this over 6. Alright, 71.6687. So approximately, let's leave it in 3 decimal place or 2 decimal place. Let's leave it in 2 decimal place, and we're going to get 71.67. Alright, I add. Let's go for the geometric mean. And geometric mean, we say that if A, B is greater than 0, then the square root of A times B will be the what? The geometric mean. So from what we have here, we just need to take the square root of all the sequences here. 62 plus 65 plus 70 plus 75 plus 78 plus 80. I hope you can see that. Please, it's 80. Let me keep repeating it. It's 80. Okay, alright. I said it's 80. So, when you take your calculator and you punch everything there, you are going to get. Oh, I forgot to also remind you of something. Now, here we have two terms. That is why we are taking the square root. Don't forget it. So that is why we take square root. So it's like if roots. And the end here represents what? The number of what? Terms in the what? In the sequence. So here is in general, here is n. And how many sequences do we have in the question? 1, 2, 3, 4, 5, 6. So you have to take the sieve roots. So the sieve roots. Please don't forget that. It's not always square root. As we said that here is not always 2. In the same way, here is not always square. That is 2. But it depends on the number of what? Terms. And when you do that, you are going to get 71.36. 71.36. So that is going to be for the geometric mean. Alright. Lastly, let's see for the harmonic mean. And the harmonic mean too, we said that if A, B is greater than 0, then how many are they? 2. So 2 over, then you take the inverse of this, 1 over B, plus the inverse of this, 1 over what? A, and 1 over what? B. That is for the harmonic what? Mean. In the same way, when we are considering the III, that is the harmonic mean for this sequence. How many number of terms? 6. So 6 over 1 over the first term is 62. Plus 1 over the second term is 65. Plus 1 over 70. Plus 1 over 75. Plus 1 over 78. Plus 1 over 80. So 1, 2, 3, 4, 5, 6. Alright, so that's what you're going to get for that. And when you punch that on calculator, please punch it well. And you will get 71.05. Because of time, I'll quote from my answer here. In case you punch and you get any different thing, you have to do the right thing. So 71.05. Wow, we are done. Now, what is going to be your conclusion? So I can add one person to it. IV. Comment on your results. Comment on your results. Now, let's look at something here. For the arithmetic mean, we have this. Geometric mean, we have this. Harmonic mean, we have this. And we have already established that the arithmetic mean is greater than or equal to the geometric mean. And the geometric mean is greater than or equal to what? The harmonic mean. Beautiful. Therefore, let's see. Is this greater than this? In two decimal place, you can see that this is greater than this. And if this is greater than this, is the geometric mean also greater than the harmonic mean? Let's go and see. 71.36. 71.0 is also greater than that. And if this is greater than this, then this is greater than this. So we have already established that. Thank you. See you in the next video. Bye bye. Love you.